Let's talk about a basis. What is a basis? So we're going to discuss a basis for a subspace H sitting in Rn. So a basis is going to be a subset of H that's linearly independent and generates H. So there's some things to notice in this definition. The set has to be linearly independent. It also has to generate or span H. And finally, one that people often forget, it has to be a subset of H. I'm not going to take vectors that are outside of H and throw them into a basis. So in other words, a basis for H is a subset S of H that has the following two properties. One, S is going to be linearly independent, and two, the span of S is going to equal H. So let's take a look at an example. Let's verify that the set S, consisting of these two vectors, 5, 0, and 1, 2, gives me a basis for R2. So if I consider the matrix that I get when I stack these two vectors together, I notice I have a pivot here, pivot 5 and a pivot 2. This has a pivot in every column. And so what that means, what we've shown, is that tells us that the columns of the matrix are linearly independent. And since the columns are exactly the vectors arising in S, that tells us that S is linearly independent. Now the matrix also has a pivot in every row, and we've shown that that means that the columns generate R2. And therefore, since the columns are exactly the vectors in S, S generates R2. So the set S is linearly independent, and it generates R2, and so therefore S is a basis for R2.